Hi, today I am going to actually compare two devices. One is this NanoVNA, maybe $60 or $50, and this is from MFJ Martin F. Joe. Martin F. Joe is making it in collaboration with Times Technology. So this is a pretty reliable device and you can actually rely on it. Compare the readings of these two devices. And for an ordinary ham like me without technical knowledge, the only thing that I can measure easily is this thing, SWR. That is the standing wave ratio. Standing waves are the waves that don't move. So it is a little bit complicated and related to the feed point mismatching with mismatching of the antenna feed point with the radio feed point, because standard is 50 ohms, and if the antenna, which is the ear and the mouth of the radio, actually when we put a signal into the out of the antenna, it is the mouth, and when it is receiving some signal, it is the ear. So it is listening and sending. So it is mouth and ear, and antenna is the mouth and ear. But that mouth and ear, the feed point, that is very critical, and there may be mismatching. So the first thing we're gonna see is actually whether there's any mismatching. This is for continuously monitoring for any mismatching of my transmission, so that I keep my radio safe. I get to know any mismatching here, and accordingly I can take the measure to keep my radio safe. Now I'm gonna show you if I speak into my mic, and I'm not gonna make a car chunk. I will announce my call sign. This is on our hand frequency 145.600 megahertz. Let me go to our repeater frequency. This is our repeater frequency. We can press our repeater. This is the reverse 145 megahertz. This is 145.6. Hello test, this is Victor Uniform 2 Mike Uniform Echo. Now if I transmit through the repeater, you can hear a beep, Roger beep. Hello, testing the repeater, Victor Uniform 2 Delta Lima Romeo. This is Victor Uniform 2 Mike Uniform Echo. So this is a clean Roger beep coming from the repeater. The repeater is responding perfectly okay, and you can see the standing wave ratio, the mismatching is. Hello test, this is Victor Uniform 2 Mike Uniform Echo. This SWR is 1.19:1. Ideal SWR should be 1:1. This is 1.19:1. That's pretty fine. I don't have to worry about anything. My antenna and the radio impedance, the 50 ohms, this coaxial 50 ohms, and antenna feed point 50 ohms, they're matching, almost matching, 1.19:1. I assume it 1:1 for this particular frequency. This particular frequency 145 megahertz. Now I'm gonna see if I don't use any radio for these things, a device under test. I have another antenna. This is a Trishul antenna, and that's a broadband antenna actually being used long back in cordless Chinese telephones. So I'm gonna see that antenna with my this NanoVNA. Initially I calibrated it, I got it as a kit, and what I have already done, I'm going to repeat the same thing again. A very reliable device from Times Technology, made in collaboration with MFJ Enterprises. And this NanoVNA is a kit, and these codes are available for free, open source. So the beauty of this is that you can do a whole lot of things. Only initial thing that I can try with this device is to see my antenna mismatching, in which frequency my antenna is resonating perfectly okay, or I can safely connect it to my radio. So I tested it initially. These readings you can see with my MFJ Times Technology 2-226 graphical antenna analyzer versus NanoVNA accuracy. So I tested on 145.020 MHz. I found the SWR. It's a little bit complicated actually, the formula. It's not a simple ratio of the forward power or the reverse power. It is not like that. It's a ratio something different, little bit complicated, but very simple. If your SWR is 1:1, then you should be happy, and if your SWR is more than 2:1, you should be worried. You should not transmit. You should use an antenna tuner to reduce your mismatching. Lose some of your power being absorbed by your antenna tuner unit, but your radio would be happy, and you would be happy, and your radio would be safe. So on 145.020 MHz, yes, NanoVNA, I measured mismatching of 1.54:1. 1.54:1 on particular this frequency, and on MFJ-226 I measured 1.53:1. That's pretty close to each other actually, very close to each other, and that accuracy would depend upon actually how I calibrate it. There is a scale, so you need to spread it so that you get an accuracy. If your scale is too cramped, you will not get an accuracy. So you should make it wide, and reasonably wide, so that you get an accuracy. So I don't mind getting a difference of 1.54:1 with my NanoVNA, and MFJ-226 1.53:1. Very close. Ideal is 1:1. This SWR should never be above 2:1. Radio may be damaged. Usually radios are not damaged. They have the circuitry to automatically reduce the power. Still, in case of homemade equipment, maybe you should consider this. So that we need to actually continuously monitor when we use different type of antennas. Now I am going to use this NanoVNA, which I connect it. Initially, let me switch it on. You can see this USB-C charging port, and you can connect it to the computer as well, and you can just switch it on. So you can see here something 10 dB blah blah log mag. There are so many complicated things here actually. I'm going to show you. Now it is very simple, and it is, if I go to say display, trace, you see something came up, then another came up, green color, then pink, another came up. So these are so complicated because I just want to measure my mismatching and find out the ratio, SWR ratio. so it has gone. I'll press it here. Yeah, now this is not connected. I have already calibrated it using this load, 50 ohms load. Then there is open, then one is short. These are the three things I will explain in a different episode. Now I calibrated it actually initially for a frequency range of 144 to 150 megahertz. I calibrated it so that I get a reasonably good accuracy over this display. So let me press it again to get this thing. I go back because the thing that I wanted to get is not here. Now you can see it is not here also. Format is there. Yes, format is that I want to get, I don't know all these things, phase, log mag, delay, Smith chart. Only thing I know is SWR. So let me go to SWR. Now you can see on 144 megahertz infinite SWR, and this one, it is showing 1, and if you see this scale, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 scales. So this 1 means this, all these blocks, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 blocks. If you divide 1 by 8, you calculate it out, and accordingly you need to scale. What I did, I'm going to show you. I have gone to scale per division means these divisions. If I press it here so that I don't make a mistake, let me do it again. Point 1, 2, 5. Okay. Now I'm gonna see where actually things are okay. So somewhere in between I will get to SWR 2:1. So I'm going to connect. This is a SMA to SO239 type of connector. The scale has gone a little up. I can actually touch it and bring it up. As I said, I measured frequency, the SWR mismatching ratio SWR for 145.020 megahertz. For this it was 1.54:1. Now I can touch it. Sorry, I'm holding the smartphone. Or let me use this thing. This is easier. Let me go to 145.020. Yeah. So on 145.020 megahertz, it is showing my NanoVNA is showing 1 point, let me correct it, on 145.020 megahertz it is showing 1.53 SWR 1.53 is to 1. Perfectly fine. I can operate my radio safely with the Trisul antenna. Now say I go up to this is the maximum point of mismatching, this is the minimum point. So if I because I'm comparing it with this MFJ device, so let me let me show you the reading for 150 on 147 megahertz. SWR is maximum 1.7. And on 150 it is 1.67. 1.67 is to 1. 1.67 is to 1. Ratio, it is a ratio. SWR is always not said in like 1. SWR is 1:1. It may be 2:1. Something else like that. Maybe 10:1. 10:1 is not at all ideal. It should be always below 2:1. Below 2:1. Ideally it should be 1:1. Now on 150 megahertz it is 1.67:1. So these are how much it is showing, 1.67. so let me, for 150 megahertz, let me note it down. This was for 145.020 and for 150 1. Single frequency, enter. As I said, on 150 it is showing 1.68:1. This is what my NanoVNA showed, 1.67:1. So it is very close to my NanoVNA reading, 1.68:1 on this MFJ costly device, reliable. This is also reliable definitely, as I found that it is matching to the SWR that I already measured for 150. It is 167:1 and it is 168:1. Now let me change the frequency to 1. I already noted the frequency for SWR for 145.020 this is not /2, 1.53:1. Now let me enter the same frequency, 145.020, direct entry. You can see the frequency here, 145. This is decimal, this is 0, this is not 0, this is the 0, 0 to 0, enter. So you can see it is pretty accurate, 1.53:1, 1.53:1. It is the same that I measured here on my NanoVNA. I am going to again show you. Let me, this I have shown you on my MFJ on 145. 1.53:1 is the SWR. So let me switch it off and let me try it on my NanoVNA. Down, sorry, I need to measure the frequency of 145.020. 145.020 megahertz. SW means switching is 1.53:1. So it is pretty accurate. It is showing the same thing on my MFJ and on this device. So I don't have to worry much about this device. It is pretty accurate. Thank you. 73